morning, this is Akanksha Shukla from Information Technology Department, and today I am going to discuss the topic that is stream concept. Basically, the stream concept is defining about the data stream and which algorithms are used to define that stream concepts, and which algorithms are used to basically identify the data streams which are coming in a voluminous amount of data. So, what is data stream? First of all, I will discuss that the basic definition of data stream. So, the data stream basically is a continuous, or we can say that ordered or chain of items which is continuously arriving over a particular period of time, or we can say that it is not feasible for anyone to locally capture that particular data stream in its entire form. So, it is basically an enormous volume of data which is arriving at a higher rate. So, for a person or for an individual, it is not possible to locally capture that particular data stream in its entire form. Okay, so it can be captured in a, suppose we can say that the data is coming at a very huge volume. So we can basically capture the first part of the data, we can capture the last part of the data, but at its entire form we cannot locally capture that particular data. So it is unfeasible to control the order in which that data stream or in which that data units are arriving, and also it is not feasible to capture that particular data in its entire form. There are basically three kinds of data streams. First is data stream, which I had discussed that it is a sequence of tuples, we can say, and each tuple is comprising of the set of attributes just like similar to a row in a database table. The data stream contains different sets of data which are depending upon the chosen data formats. So, here some of the key points or keynotes for data stream, that keynotes or that these points are closely related to the data stream. The first of all is the attributes. So, each attribute of the data stream basically represents the certain type of data, just like segment, data point, ID, time stamping, geodata. So, these are some attributes which are defining the data stream behaviors. The second one is time stamp. This attribute helps to identify that when an event occurred, when that or that period of or point of time that event particularly occurred, or that particular data stream is arriving. So, time stamp basically attribute is an attribute which helps in identifying the occurrence of the event. The next one is subject ID. That subject ID is encoded by the algorithm ID, and it has been extracted out of a cookies. Next is raw data. Raw data is basically including the information just like straightforward from the data which is provided by the processed by the algorithm, nor the any human being. Okay, so raw data basically includes information straight from the provider and without being any processing by any algorithm nor also by the human being. So, raw data includes the basically original information without any processing process covered in it. Next one is process data. So, that process data is different from raw data because it is a data which has been prepared, modified, validated or cleaned to be used for the further or future purpose or future uses. Next one is transactional data stream. Basically, it is a log interconnection between the entities, just like credit card, telecommunication, web accesses by the clients of the informations or the servers. So, transactional data streams consist of the data which is basically interconnected, which is showing the interconnection between the different kinds of entities. Just like we are having credit card and we are going to purchase some items from the producer, just like we are consumers and we are going to purchase some item from the producer. So, using the credit card. So, that kind of transaction or that kind of data which is produced during these transactions generally comes under the transactional data stream. Okay, just like in the second example, it is given that telecommunication. So, phone calls by the caller to the dialed parties. So, whatever the data is collected or whatever the communication is established between the caller to the callee. So, that particular data stream comes under the transactional data stream. Now, web accesses by the clients of the information at the servers At the server end, whatever the client is accessing the information over the website, that particular data is also comes under the transactional data stream. Next one is measurement data streams. So, the examples of these kind of data streams are sensor networks, IP network, earth climate. So, first is sensor network. The physical nature of phenomenon, just like we are having it is a kind of physical natural phenomena, means if any physical natural phenomena is occurring and we are going to measure that, suppose for example, earthquake is occurred, okay. So, at which speed that earthquake is occurred over this region comparatively to that particular another region. So, that comparison and that particular value which is calculated or which is measured during that particular event occurred. So, the data which is occurred or which is originated with these kinds of occurrences, with these kinds of event occurrences, then it will become a measurement data stream, okay. Second one is IP network, traffic at router interfaces, so that whatever the traffic is occurring at the router interfaces, so that all comes under the measurement data stream. Next one is what is the climate, or what is the temperature, what is the humidity level at the weather station. So, different measurement data, different measurement data comes under the measurement data stream based on different conditions. Just like what is the temperature of today, so that value, if the temperature of today is 36 degrees Celsius, so that particular 36 degrees Celsius, that this data will be particularly comes under the measurement data stream, okay. So, whatever the numerical values or whatever the values which is considered as some measurement for a particular occurrences or for a particular things, that data will comes under the measurement data streams simply. Now, examples of stream sources. What are the different examples which comes under the stream sources? Just like in data analytics, I had already discussed about the different sources of data. So, just like what are the different sources of data? Primary data sources, secondary data sources, okay, and other sources of data also I had discussed in my previous lectures. So, here I am going to discuss about the stream sources. What are the basic sources of data stream? So, first one is sensor data. Basically, navigation systems sensor data is used. So, first of all, if you are imaging a temperature sensor which is floating in the ocean and it is sending back to the base stations a reading of the surface temperature per hour. So, whatever the data or whatever the reading the temperature sensor is sending to the base station per hour. So, the data generated by this sensor is a stream of real numbers. So, we have 3.5 terabytes data arriving every day, and we for sure need to think about what we can kept continuing and what can only be archived. So, this is the basic concept, that if these kind of data is arriving in such a huge amount of volume, then what is the decision or what is the suggestions required for that particular storage of these kind of huge amount of data. So, here that is written that now we need to think about what portion of data we have to kept in continuation and what portion of data we have to be kept in a archived manner, because the data is generated by this sensor data in a very huge amount. Just like here in this example, it is given that 3.5 terabytes arriving every day. So, to keep storage of that huge amount of data per day is a very challenging task. Next is image data. Satellites frequently send down to the earth streams containing many terabytes of images per day. So, surveillance cameras generated that kinds of images with the lower resolutions than satellites, but there can be numerous of them which are producing the stream of images at a break of 1 second each. So, it is also next is a challenge, that how to save or how to store the image data, how to store the satellite data per day, so that none of the data can be mismatched or none of the data can be missed for future purposes. So, we have to keep storage of each and every data, but That's the main point, that what we have to kept in a continuation process and what portion of data we have to kept in our archived, or in which portion of data we have to kept in our permanent storage and which portion of data we have to kept in our temporary storage. So these things we have to keep in our mind. Next is internet and web traffic. Bobbing node in the center of the internet receives streams of IP packets from many inputs and then pass them to their responding outputs. So nowadays websites also receiving streams of heterogeneous types of data, not a homogeneous kinds of data. Suppose for example, Google receives 100 million search queries per day. For example, at one place the person is searching for a textual information. At the same place, another person is searching for some numerical portion, some numerical questions, some any other geographical locations. So at the same time, website is receiving the streams of heterogeneous kinds of data. Okay, so to keep that particular huge amount of data in a continuation process, it's also a very challenging task, and it also comes under the sources of data streams. So these are the various, or these are the some basic primary sources which contributes towards the data stream. Now, what are the basic characteristics of the data streams? First is it is a large volume of continuous data which is possibly infinite. And the second one is steady changing and requires a fast real-time responses. Just like I had given example over the website or Google searches. So it is continuation fast process and continuously changing. At the same time, the person wants textual information, textual knowledge from the website or from the Google search option, and at the same time the another person is requiring any other kinds of his or her problem. So it is a kind of steady changing and requires a very fast real time responses per second, or we can say that per milliseconds. Okay, so data stream captures nicely our data processing needs of today, but random access is expensive and it can be possible in a single scan algorithm. Because what happens actually here, that we have to, suppose we are dialing or we are searching for any information over the Google, then within a seconds we want the responses. So within a single scan algorithm we want to access that output, or we want to access that response. So that random accessing of the response is expensive and it requires a single scan algorithm. It stores only the summary of the data seen so far, because it is not feasible to store all the data which is coming in continuous or which is coming in large amount of data. So maximum stream data are at very pretty low level or multidimensional in nature or creation. So they further needs to be multi-level and multi-dimensional treatment. Now, what are the different applications of data streams? First one is fraud perception. So whenever, just like in a transactional data stream, if there is occurring any fraud or there occurs any misconception, then we can with the help of monitoring our data stream, we can easily identify that which point of time the fraud occurs. Second one is real-time goods dealing. If you are dealing with the goods, then with at which time that particular products or particular goods is to be purchased or sold, by which consumer, by which customer. So these details can also be easily identified with the help of proper monitoring of the data stream. Then then in terms of consumer enterprises also, the data stream has its applications. Observing and describing on inside IT systems, it has its very real-time application. Sensor network, already discussed that how the sensor data is used and how sensor networks are, how in sensor networks that particular data stream is applied or that particular data stream is used. To identify or to monitor the traffic analysis over the communication channel or over the networks, we can easily see that how data stream is applicable over here. In financial applications also, data stream has its very primary or key role. Then transactional log analysis. So over the transactional log analysis also, we have very clear view of the data stream, that how particular data stream is responsible for that particular transaction and how that particular transaction logs can be analyzed with the help of data streams. Now, what are the advantages of the data streams? Basically, the data is helpful in upgrading the sales, helps in recognizing the fallacy, helps in minimizing the cost also, and it provides the details to react swiftly to the risk. So, to manage the risk occurrence, or if we are concerning about the risk management, then basically the data stream has its advantages to providing the details that how to react very swiftly over that particular risk. So, to overcome the risk systems, or risk problems, or whatever the problems to be identified in future, it if you are having a very clear view of, if you are having a very clear monitoring of the data stream, then it can be very helpful to react swiftly to the risk. There are some disadvantages also. First one is lack of security of data in the cloud. If the data is over the cloud systems, then it is one of the disadvantage. We can say that it is also one of the disadvantage of the cloud environment, that there is the lack of security of data. So, that disadvantage comes under this particular topic also, that if the data is spread over the cloud, or if the data is having over the cloud environment, then there would be a lack of security of data. Second one is hold cloud donor subordinations. The third one is off-premises warehouse of details, basically introduces the probability for the disconnection. If you are having off-premises warehouses of the details, then it introduces the probability for the disconnection also sometimes. So, it is also one of the, if there is a probability for the disconnection, then at that particular point of time of disconnection, whatever the data stream is coming or not, then we cannot monitor that kind of things. Okay, so that is also one of the disadvantages of the data stream. Now, how that stream computing is performed? So, a high performance computer system which is analyzing the multiple data streams from many sources. So, the word stream in stream computing is basically to mean pulling in the streams of data. Means the stream means simply the pulling of the stream of data, okay, and then processing the data and then streamlining it back towards that particular processed form. So, stream computing basically uses the software algorithms which are analyzing the data in a particular time, and it streamlines the data to increase the speed and the accuracy when we are dealing with the data handling and the analyzing of the data. Here we can see that the stream processing computational paradigm consists of assimilating the data readings from the collections of the softwares or the hardwares sensors in a stream. So, here this is the streams and these are the operators which are applied over that particular streams. These are the sources from where the data stream is coming, okay, and the person is analyzing that streams, that is data stream which is arriving, or which is arriving in a continuous voluminous amount of form. So, that person is particularly analyzing the data and then he will produce the actionable results possibly in stream format as well. Okay, so these are the sources from where the data stream is coming, and the black arrows are showing that particular stream and the red circles are showing the operators which are performed over the streams. Now, comes towards the data stream model. Basically, a data stream is a real-time continuous and ordered sequence of items, which is not possible for an individual to control the order in which it is coming, and also not feasible to locally capture that particular stream in its entire form in any memory device. Okay, so this is the basic diagram in which we can see that these are the data sources from where the data stream is coming, and here there is a streaming message service providing, and then that particular message is processing towards the stream. Further, in that particular stream messaging services, we are having an ingestion services, and that particular ingestion service is connected to the long term data storage, And here also, after processing of that particular streams, we are having long term result storage. So here we are storing the long term data, and here we are storing the long term result storage. Means here we are basically storing the stream messages, okay, which are injected to the particular storage system, and after processing of that stream, that results will be stored here only, and then whatever the reports, whatever the monitorings, and whatever the other workflows in terms of its output will be displayed to the receiver. Now, characteristics of the data stream model. Basically, data model and query processes must allow both ordered based and time based queries or operations. Okay. Inability to store a complete stream, it indicates that some approximate summary strategies or structures must be used. Okay, if it is not possible to store a complete data stream, then what we have another option, we are going to have some approximate summary of the particular data stream, or we have summary structures that should be used for further use of that particular stream. If in future that particular data stream can be in need of any situation, then we can have that particular approximate summary structures which can be used further. The streaming query plans must not use any operators that requires the entire input before any results are produced. So, any query which is requiring backtracking over the data stream is infeasible. This is due to the storage and performance constraints which is imposed by the data stream. In the data stream, there are some constraints like storage constraints, performance constraints. So, if you are having, or if anyone is requiring the backtracking over the data stream, then that kind of backtracking over the data stream is infeasible due to that constraints. Applications which are monitoring the streams in the real time must react quickly to unusual data values. Means the applications which are monitoring the streams in a real time world, they will react very quickly if there is a occurrence of any kind of unusual data values. Scalability requirements also dictate that the parallel and the shared execution of the many continuous queries must be possible. So, over the data stream models, there is a scalability which indicates that we can have parallel access of the data queries, and we can have shared execution of any continuous queries in our data stream model. So, scalability is properly provided by the data stream model. Now, the data which is stored over the data stream model can be partitions into the three parts. One is temporary working storage, the second one is summary storage, and the third one is static storage for metadata. In temporary working storage, what we do? We store the data for temporary purpose. Just like if we are having some queries for today only. So, what we do? We store that particular data into the temporary working storage, and at the time of execution of that query, we will use that particular data from that temporary working storage. But the summary of the whole data stream will be stored to the summary storage partition. Okay. So, in future also, whenever there is a requirement of that particular data values of that particular data stream values, then what we do? We refer to the summary storage memory device, and then we can decide further decisions. Static storage for metadata. If we are having some data about data, or we are having some metadata values, then that particular values will be stored over the static storage only. Now, what is data stream mining? Basically, the data stream mining is just like similar to the data mining process, in which we are extracting the useful information from the data warehouse. And here, what is the concept of data stream mining? That it is the process of extracting the useful knowledge from the continuous rapid data streams. In when we are talking about the data mining, then what we do? We extract the useful information from the data warehouses, from the large data warehouses, and here that large data warehouse is replaced by the rapid data streams. So data stream mining is a process of extracting the useful knowledge from the continuous rapid data streams. The three basic main challenges during the mining of big data streams are volume, velocity, volatility. So volume and velocity require very high volume of data to be processed in a very limited time. That's why this is these three are the main challenges. And concept drift. Concept drift is a phenomena that occurs because of the feature changes or changes in the behavior of the data itself. So volatility means the changes in the behavior of the data itself and the changes in the features of the data. So that drift is that changes or that variation is called as a concept drift. So volume, velocity and volatility, these three are the main challenges during the mining of the big data streams. Now, what is streaming data architecture? Basically, streaming data architecture consists of software components which are built and connected together to ingest and process the streaming data from the various sources. It processes the data right after it is collected. Whenever the data is collected, then after that particular collection process, the streaming data architecture then process the data further. So this processing process includes the allocation to the designated stocks and designated storage, and it may include the triggering further processing steps, then analytics for the data manipulation or sorting of further real time processing. So stream data architecture basically consists of the software components which are connected together for further processing, and after the data is being collected, then that data will be processed first, and then that processed data will be injected or allocated to the design storage, in which some triggering of further processing steps, analysis, further data manipulation or sorting steps will comes further. The simplest explanation is the real-time operations are about the reactions to the data, whereas stream processing is about actions taken on the data, not about reactions to the data. Stream processing is about actions taken on the data. Real-time solutions basically guarantees the execution of the data in very short time period after it has been gathered. A reaction to the data is almost immediate. We have not to the reaction towards the data is not a very delay process. It is a immediate process. Okay, that processing may take minutes, seconds or even milliseconds depending upon the business requirements and the applied solutions. Example of the use case for real-time operation can be just like buying, selling operations over the stock market, and when the quote needs to be provided right after order is being placed. So these are the some cases for the real-time operations which needs an immediate actions, not a very delayed process. So these are the some examples of stream data architectures. In contrast, stream processing is about continuous computation that happens as data flows through the system. There is no compulsory time limitations other than the components, power or the technologies that solutions applied over the business tolerance to latency. And further, it concludes that there is no deadline for the output or the reactions of the systems when data comes over. So the data is processed as it comes. There is no possible chances of being delayed. Whenever the data comes, the data is being processed as it comes. There should be not a single milliseconds of delay should be further processed or needed. There is no deadline for the output or reaction of the system when data comes over. It should be processed at instant immediately. Okay, so stream processing will basically beneficial in case of frequent items to be tracked if the events need to be detected right away and responded to be quickly. So the success of this architecture depend upon the two things. Over the long term, output rates need to be at least equal to the input rates, and it must have enough memory to store the quoted inputs required for the queried outputs required for the to store the queued or inputs required for the computations. Examples, use cases would be cyber security or fraud detection. Okay, so this is one of the algorithm which is used to count the distinct elements in a data stream, that is Flazo-Martin algorithm. That algorithm I had already discussed in my previous lectures. So that's all for today. Thank you.